Hey everyone, welcome to the third video of the Blockchain Basics batch, which is part of OWS Education created by the OWS team. In this video, we will look at consensus protocols. Because blockchains are decentralized and autonomous, they must have a reliable decentralized method to ensure that all transactions on the network are orderly and truthful. A consensus protocol is the agreed algorithm used by a blockchain network to validate the transactions as truthful. The consensus protocol aims to solve two issues: keep transactions in order to avoid a double spending problem, and prove that the content of transactions has not been tampered with. So let's outline the most commonly used and developed consensus protocols: proof of work, proof of stake, and proof of history, and a positive and negative for each. Proof of work was the first consensus protocol to be used on a blockchain network, Bitcoin. Proof of work aims to solve the consensus problem by making miners use time and energy to validate transactions. Let's follow the transaction process for a proof of work blockchain to see how it works. So, once a transaction is made by a user, it is signed using their private key. Instead of having some centralized authority approve the transaction, miner nodes on the network race each other to prove to the rest of the network that the transaction is valid. They prove this by trying to be the first miner node to solve a time and energy consuming cryptographic problem. To solve the problem, they must find the input to some one-way function that gives a correct output. Once a miner node claims they have found the solution, the other nodes part of the network can check the solution is correct by feeding it into the same function to check for the correct output. If it is, it validates the transaction received. The main positive is that when there are a lot of nodes, it is very secure, whereas the main negative for proof of work is that it has slow transaction speeds and low scalability. On the other hand, proof of stake is a consensus protocol which aims to increase the scalability of a blockchain network. Proof of stake offers a method to validate transactions that uses far less time and energy compared to proof of work. Let's again follow the transaction process to see how it works. So once a transaction is made by a user, it is again signed using their private key. But instead of having miner nodes, a proof of stake blockchain network has validator nodes. Validator nodes stake a portion of the cryptocurrency so that the proof of stake algorithm can choose them at random to validate a transaction. For some proof of stake networks, the higher the stake means the higher the chance that you will be randomly picked to validate the transaction. Once a validator node is chosen, they validate the transaction and store it on a block. If that transaction has been tampered with and it is validated and the network realizes, then the validator node loses their stake automatically. The main positive for proof of stake is that it is scalable and low on hardware and energy use, and the main negative is that it benefits those with more stake. Proof of history is a consensus protocol that aims to increase speed and scalability by creating a verifiable list of transactions through time. Let's go through the transaction validation process. The proof of history algorithm randomly gives validator nodes turns to be transaction validators, where validator nodes are selected similarly to proof of stake. Once a node is selected for the role, the proof of history algorithm makes the validator node calculate the transaction's order. Let's briefly see how this works. Firstly, a cryptographically secure one-way function f takes as input the transaction tx1 and outputs a hash h1. Then that hash and the next transaction tx2 is inputted into the same function f to output another hash h2. Because each time the function is run, the hash of the previous one is required, it can be said that real time has passed between the two transactions, as we need to run the functions in a single order. As a result, each hash tells us what transaction had to come before it. This results in a verifiable order of transactions as a function of time. Once this sequence has been outputted, all other nodes can verify the sequence of the transactions by inputting their corresponding hashes, checking the order of tx1, 2, and 3. The main positive for proof of history is the high throughput without compromising network security, whereas the main negative is that it is low decentralization due to specific hardware requirements for each node. In this video, we outlined the three most common blockchain consensus protocols: proof of work, proof of stake, and proof of history. In the next videos, we will discuss the use of blockchains and what users can achieve with them. Thank you very much.